Thank you very much for coming to this session about continuous integration and delivery. But I know that maybe some of you say, yeah, but continuous integration and delivery has been out there for a long, long time. But today we're going to focus on Kubernetes, how to implement continuous integration and continuous delivery in a Kubernetes native way. My name is Alex Soto. You can follow me on Twitter, which is AlexSotoV. My email is soto@redhat.com. So if you've got any question after the session, you can also, I will be around here for the 3 days, so you can approach me. Or also you can ask me the question in my Twitter or my email. And well, also I work in Red Hat. And yeah, I'm the co-author of Testing Java Microservices, Quarkus Cookbook, and Securing Kubernetes Secrets. So let's start just first of all as a state of the art. Let's think about how we developed maybe like 7 years ago, 8 years ago, where we've got our monolith application with all the code there inside with just one database, maybe just one mail server, one FTP, right, server, and so on. But it was just a big application that we deployed to production every 4 months. I know that some of you might say, 4 months? We go to production every 6 months or once a year. And even if we did a party, right? Yeah, was the past. But nowadays, we are more in a microservice architecture where we are deploying to production maybe every week, maybe every day, or even maybe every hour. And I'm not saying that you are deploying the whole application to production. Probably you're just deploying one small piece of your application. Maybe this service. You are deploying this service every Monday, this service every Wednesday, and this service every Friday, for example. So you're deploying several times per week. And of course, if we want to deploy several times per week to production, and we need to make it in an isolated way, so each service can be deployed independently, means that each of these services needs to have its own pipeline. We need to define a pipeline for each of the services. And moreover, if you think about microservice architecture where we can implement services in different languages, then we will need to define pipeline for each of these services because, deploying with Java is not the same as in Go or in JavaScript. So we need to find ways to deploy to production in an easy way. And currently, I can say that deploying to production or the de facto platform for deploying microservices to production is Kubernetes. So before we start with continuous integration and continuous delivery, let me explain what is DevOps. Okay, DevOps is the key to meet the insatiable demand for delivery quality applications rapidly. Basically, it means that we want to go to production as fast as we can, so we can start providing value to for our application to all our customers. And we can think that DevOps is about Dev and Ops. And the truth is that no, it's not that way. It's about the full people that are involved in the process of creation of application. We can think about the operations guy, the PMO, the business, the security, the developers, the QA, the DBA. I'm not saying that DBA are zombies. I'm saying that DBA loves Walking Dead, okay? So we need to think that we all are a team. We've got common interests, common hobbies, and we need to, work from the beginning in all these aspects, all as a team. Because then, if we are not working in that way, our delivery process is something like that. We've got our application that needs to be put on production, and you see that, here maybe all the developers here trying to, push the application to production, and then you ask, who is this guy? Yeah, maybe you say, yeah, I'm a developer. This is the security team. That is always say, no, go to production. We are not secure enough. Or maybe the DBA. Oh, please, now put this SQL script. But maybe this guy could be the developer, and these ones could be the ops. No, we cannot put MongoDB on production yet. No, put it, right? And this? Yeah, probably this is the architect, right? It's there surfing in that ball, right? But this one, yeah, maybe it's the product owner. I don't know. But delivering process is quite hard. And the bad thing is that it's not just one, it's repeating and repeating and repeating. So we need to change this to something better to roll up to the mountain, so it's easy for all of us, and all of the team is pushing up. And to implement this, we need to rely on continuous integration and continuous delivery. And, well, probably most of you already know that in the continuous integration pipeline, we've got the build phase, the test phase, the security checks, where we do usually a static analysis code, for example, and then we release. And when I said here we release, I mean that we take the output, maybe it's a jar file, maybe it's a WAR file, maybe it's a container, and we publish to our artifact repository. And this is the end of the continuous integration pipeline. And then it comes, for example, deploying to staging, pre-production environment, and finally to production. And this is the continuous delivery phase. This is when we take our application and we put it on production. So nowadays, probably some of you already sounds, or most of you, the concept of GitOps. Yeah, we are trying to use DevOps, so we all work in a team. We already have continuous integration, continuous delivery because we are using Jenkins, and that's fine. And also we are sounding things like GitOps. And what is GitOps? Okay, GitOps is just taking Git as the single source of truth. It means that everything is in Git. When it's not in Git, it's not true. And when I say everything, it's all your code, your infrastructure, your configuration, everything. So there is no manual steps. If you want to change something, you need to change it in Git. So in this way, you know all the time exactly what is in production. You can treat everything as code, which means that you can branch, you can tag, you can revert. For example, you said, oh, I've just updated the version of my application from 1.0.0 to 1.0.1, and now it's failing. So I can do a revert of the commit that I did, and I'm getting the old version again. And as I said, all the operations go through Git. I can do pull requests of an update of my database version. So you can see that at the end, GitOps is a developer-centric approach to continuous delivery and infrastructure operations, because we are just taking the developer approach of putting everything in Git and expand to our way of delivering software and the way of updating our infrastructure. So why GitOps? Okay, but basically because probably most of us nowadays works with Git. Okay, so it's something that we already know. We don't need to try to understand a new tool. It's just Git. Since it's Git, we can send pull requests, and since there are pull requests, we can, for example, review what we are going to do, what we are going to update. Suppose that one developer send a pull request saying, I want to update the PostgreSQL version from 9 to 10, and send a pull request. Someone can review and say, no, we cannot go to 10 because there is some breakback compatibility or there is security issues. And finally, there's a grade for visibility and audit. Since it's a commit, we need to set a message. And we can always review why a change was done. Suppose that, for example, we're changing from having one replica of my application to 2 replicas. This process should be done with the commit. And we will put in a message, yeah, we need 2 replicas because, I don't know, because we want to have our application more resilient. Then, if someone, after 3 months, says, why we are running 2 instances of this application, they just need to go to the Git, do a blame, check the message, and know exactly why this was happening. And also, it helps you to have multi-cluster consistency. There is only a single source of truth, and all the clusters are configured with this Git repo. So let's start with the continuous integration in Kubernetes. Nothing new. We've got the source Git repository where we're putting all our code. Then we are running some steps. Okay, compile, running test, maybe creating a container image, and finally release it to our artifact repository. Let's say Quire.io, Docker Hub, whatever. Nexus, I think that also has it's a container registry, whatever you want. then you put it there. And this part, if you want to be Kubernetes native, it's done with Tecton. Then Tecton, it's just a cloud-native continuous integration tool that lets you to build containers. And that's really important because Tecton runs inside a Kubernetes cluster and lets you create containers inside this Kubernetes cluster. And this is important because usually you need to build the containers in the same cluster where they're going to run. Okay, so if you're going to run your application in a Kubernetes 1.19, you need to create that container in the same version, in the same machines. This is how you be sure that what you build is going to run in the same way. If not, you can find some, problems. Then it's serverless Tecton, which means that we do not need to configure anything. And this shocks a bit with the users of Jenkins that you've had a lot of plugins, you update one plugin, then you get some backboard compatibility, or you need to update even more plugins, and then things stop working, you don't know why. Things like that, this happens. Tecton is serverless, which means that you don't need to manage anything. And finally, it's designed for DevOps. It's designed so you can just put some YAML files, and then these YAML files defines the pipeline. So it means that each of your service can have its own pipeline. And these are really important slides. These are the Tecton concepts. Okay, if you understand this slide, then everything works smoothly. If not, okay, we've got a demo, but you'll see that, or you might have the perception that Tecton is really hard. The first thing that is that Tecton is typed, it's decoupled, it's cloud native, and it's declarative. And these are the concepts that are really important in Tecton. The first one is the pipeline resource. A pipeline resource defines, as the name says, a resource. Notice that it's not a parameter. We are setting, for example, the source code repo, the container image, for example, or a disk where we want to store something, or the URL where we want to store something. So it's like, it's as the name says, a resource. Then we've got a step, and a step is not an object per se. It's not an Kubernetes object, but I like to put it here to, because it's let's say it's the core of Tecton. And basically, it's a container. And in this container, you define which steps you want to run. So when you run a step in Tecton, you are booting up a container and running all the steps that you've defined, all the commands that you've defined inside. And since it's a container that is running inside Kubernetes, you can mount volumes, use environment variables, inject secrets, and so on. So everything that is valid in a container in the Kubernetes wall is also available as a step. And then we've got the task. And the task is just a list of steps that are executed in sequential order. Now think about, what is a task in terms of Kubernetes? It's a pod. Because remember that in Kubernetes, a pod can contain more than one container. So if a step is a container, a task is just a pod that contains a list of containers, that each of these containers represents a step, that are executed in a sequential order, and it takes inputs and output parameters. But of course, this is just a task. For example, compile a project, or compile and run test of the project. Then it can be another task, which is build a container, or publish the container. This could be tasks. So if we want to execute them together, we need to define a pipeline. A pipeline is just a list of tasks that are run in certain order. We can define if we want to run them in parallel or sequential, in which order we want to run each of the tasks, and it takes inputs and outputs parameters. Okay, so all these concepts that you've seen here is just the definition of the pipeline. So you can define a task, you can apply this task to a Kubernetes cluster, but the tasks are not going to be run. The reason is that this is just the definition. You're registering the pipeline. And then we've got two objects, a task run and a pipeline run. And this is really the execution of the pipeline of the execution of the task. Notice that you can run a task alone, or you can run a pipeline. You can think like, the play button in Jenkins, but then it's this. This is the pipeline run or the task run. And a pipeline run or a task run can be created by a YAML file, or using Tcn. Tcn is a CLI tool for Tecton that also helps you on managing Tecton pipelines, or with an event trigger. For example, when you create a pull request, you can generate a webhook, that this webhook then will create for you automatically a pipeline run or a task run. Okay? But these are the three ways that we've got to create pipeline run and task run. So let me show you a very easy example of Tecton so you understand the continuous integration part. So I've got here my cluster. Currently, if I do kubectl get pods, you'll see that I don't know if there is any pod. I don't think so. Okay, there is no pods, nothing running. And let me show you the first Tecton, which is hello task. It's just a very simple hello task. See that I'm saying that it's a kind of task. So I'm just defining a Tecton task. You give me a name. Then here in the image, you set which container you want to start in this task. In this case, it's the BusyBox. And here you set the command, echo, and the arguments, hello world. Now, I can do kubectl apply -f, hello task.yml. And I've just created this task into my cluster. Now, what's happening if I do kubectl get pods? Okay, there is no resources. Of course, remember that I said that the task is the definition. It's not the execution. Now, how I can run this task? As I said, creating a task run. And this task run can be created with Tcn, with a YAML file, or with an event trigger. In this case, I've created a YAML file that you'll see here. Task, hello task run. And it's, well, simple. We just say, this is a task run with a name, and the task ref, you make a reference to the task that you want to execute. In this case, remember that it's named hello world. Now, let me do a kubectl apply -f, hello task run. Now I've run this task. What's happening if I do kubectl get pods? You see that now there is a pod. This pod is the BusyBox container running, and if you check here in the ready, it says that it's 0.1. It says that it's initializing this container, and there is only one container because there is only one step. Let me do now. Okay, now this finished. It says it's completed, 0.1 again because there is no pod running. Now I could do kubectl logs of this pod. And you see that it says hello world. Remember that this is the command that we set to the container that we wanted to execute, saying hello world. As I said, there is a tool called Tcn that helps you also to manage this Tecton. You can do Tcn task list. And okay, it says that there is one task. We can even do Tcn task describe. And it describes the task. You see that say that there is a task that is named hello in this namespace, no input resources, no output resources, no params, no results, nothing, just one step. And the last time that it was executed 1 minute ago, it took 11 seconds and it succeeded. If you want the logs, you can even do Tcn task logs. And it gives you the logs. Say hello, hello world. Okay, I know that you may say, this is a simple example. Let me see something more complicated. Let's do a path of, I think that it's Maven build task. Now, this is a bit more, I don't know if I can change. I don't like this black, but knowing now, 1 second, let me see if I can change it. If not, appearance, not. Window, no. Advanced, it should be appearance, right? In the profile, okay, thank you. Profile colors, okay, bold. Yeah, it's color, yeah, light, oops, light background. Now, much better. Thank you. Then we've got a task. Then you see here that there is a resource. We don't know yet exactly what it is, but it seems that it's going to be something of type Git. So we can see that this is a Git repository. And then we've got a step. This step has image, which is the Maven container image, because we want to compile in Maven. And then we've got here the command, Maven, clean package, and there is also a working dir. This working dir is the directory where we want to run the Maven clean package. Then, why working dir is /workspace/source? The reason is that when we have a resource of type Git, it implicitly creates a task which does a Git clone. Then, where is this Git clone done? It's done in /workspace, the name you have given as the input. In this case, it's called source, so it's in /workspace/source. If instead of source, this was named temporal, then the working dir will be /workspace/temporal. So let's register this task. Build task. Okay, now again, I've just registered the task. And now let me do kubectl apply -f of Maven build task run. And even I can do now a task run of logs -f, which basically I'm following what's going on. And you see that I want to follow this one. Okay, it's well, what's happening now is that it's downloading the container in the cluster. I applied the task run. Yes, it was created. Fill it. Task run. Sorry? Oh, so it's true. Yeah, and then define the Git source. Exactly. Thank you. Thank you. Yeah, it was because usually I define first the pipeline resource, then I do the task, and now I did it in the other way. Okay, yeah, true. Now we need to define the pipeline resource, which basically is just a pipeline resource of with name Git source and of type Git, and see here that I set the URL. Now, yes, now I can do kubectl apply -f this pipeline resource, and now, well, now I can delete even if you want, so I can show you more things. If I want to delete all my running executions, I can do tk-tr, the task run, delete --all, and this will remove all the tasks, because if not, you will have all these pods all the time that are completed. You can see up there, let's say kubectl get pods, and the pod is still there. I mean, it's not running, but you got all this information. Now, yes, now I can do kubectl apply of the Maven run, and I can do tk-tr logs -f, and now panic. Yeah, I'm in panic as well. Now it's working. Notice that, okay, now we'll see that probably if you are a Java developer, all these things sounds familiar to you. Is Maven downloading internet. Yeah. You might think that what's happening if I'm in a container, then I run it, download it all at one time, and then when I run it again, for example, to deliver another version, then I will get downloading internet again. And that's true. So every time that you run a task run, you're downloading everything. But in Tecton, there is a concept that is named Workspaces that allows you to share directories across all your nodes. So you can put, for example, an M2 directory there. So all the dependencies are just downloaded once. OK, now it finished. Notice that it says the build success. And if I do tn logs, tr logs, and let me do more, because I'll show you here how it says that successfully clone the repository. Because I've created a pipeline resource of type Git, I apply it, and then it automatically created a step which is cloning the project. And if we go, if I do the same, but I do it in this way, you see here how it's saying that it's building this jar file in /workspace/source, as I said at the beginning. So this is more or less Tecton, okay? Then, depending on your pipeline, you can make things more complicated, but it's just a matter of putting containers. Then, we've covered the continuous integration part, but we still have the continuous delivery part. What's happened when I finish this and I've got my container image deployed or released in my artifact repository? Then remember that we are into the GitOps scene, so what I need to do to update my application is sending a pull request to another repository. Because remember that we said that in GitOps, the truth is in a Git repo. It means that new version means that we need to update some Git repository. And usually, we've got another repository called config Git repository. This is where we store all the ways we have to deploy my application. Then we send the Tecton. We'll send a pull request to the config Git repository. We could review and say, yeah, it looks good. Let's merge the pull request. You merge the pull request. In this merge, you're just setting, I'm switching from version 100 to 101, or 110, or 200. We send the pull request, we merge it, and then we've got the continuous delivery process, which basically reads this change, so detects that there is a change, and then go to the image registry, pulls the image, and pushes that change to Kubernetes. And in the Kubernetes world, this is done using ArgoCD. And basically, ArgoCD does this schema. Basically, just monitoring your Git repository, and when detect a drift, it detects that something has changed, it takes an action. And this action basically could be deploying the application to your cluster. Of course, this also works in the other way around. If ArgoCD detects a change on the Kubernetes cluster, not in the Git, so it detects that someone is not following the path of updating the application with Git, then it validates this change with the config Git repository. It will detect that there is a drift, and they will apply the changes that there is in Git. So it will roll back the version. We're going to see it in the demo. So ArgoCD, as I said, is just a declarative way to implement GitOps in Kubernetes. It can be run at cluster level or an application configuration level. As I said, this is an example of an application, but we could update, for example, my database, or I could update the users that there are, or the service accounts that are available on my Kubernetes cluster. So all these kind of operations are managed by ArgoCD. And as I said, it automatically synchronizes configuration from Git to the clusters, detects any changes, and makes the correction. And maybe some of you said, OK, I like this, but OK, well, can you give me something that I should adopt ArgoCD? Well, my question is, if you're not using Kubernetes, are you SSH your production servers? If not, why are you kubectl them? Because at the end, it's exactly the same thing. For this reason, maybe it should be interesting just for this to start using ArgoCD. Of course, you will see that there is a lot of YAML files. Yeah, I know that some people hate YAML, say, we're going to go to the JSON, and then you know, with all these brackets, you get crazy as well. There is a tool that is called KAM, that you do KAM bootstrap, and they detect the kind of project that you've got, for example, Java project, Go project, whatever, and it generates all your Tecton pipelines and all the ArgoCD deployment files for you. But it's just a project. Usually it generates something that is OK, and then you start, let's say, changing. But at least you don't need to write all the YAML files. Then, let's see ArgoCD in action. Let me go to here. Now, I want to deploy a really simple application that just shows you a square in one color. I'm going to show you. Now, it's even worse or not. Okay, let me do a cut then. OK, now, you see, I'm just defining an application of the ArgoCD project. This is where you set where you want to, in which namespace you want to deploy your application. My application is going to go to a namespace called BGD, and in which server. So you can define several YAML files depending on where you want to deploy your application. For example, in production, pre-production, staging, and so on. In this case, I'm just using the same server where ArgoCD is running. And then I need to define where are my configuration files. My configuration files are in this repo. The YAML files are not in the root directory. They are in this directory, apps, BGD, overlays, BGD. And here also I can even specify the branch. In this case, is the main. We can see, if you want, this I've got open it here. Here you see that this is the repository, Red Hat developers, demos, OpenShift, Git examples, apps, BGD. I think there's overlays, BGD. And you see that here are some YAML files. It's nothing strange, just, Kubernetes deployment file. And here we can see, for example, a Kubernetes service, and so on. Then we've got more things. Then we've got here the sync policy automated. Because by default, if we not set this, we do not let ArgoCD update our cluster automatically. So it waits until we say, OK, ArgoCD, synchronize. And then it's when the synchronization process occurs. So if we put it automated, we do not need to do any manual step. We want to prune because we want to keep all the versions deployed. And this self-heal to true makes ArgoCD able to fix any problem that we might provoke to our Kubernetes cluster using kubectl. So it's the way we can avoid someone can kubectl or production cluster. And finally, there is a create namespace true, which basically says if the BGD namespace doesn't exist, just create it. Now, notice that I'm just going to apply this YAML file, -f BGD. And if I go to the ArgoCD UI. You see here that there is the BGD application. If I click it here, you can overview all the steps that are happening now. It has cloned that project that I showed you. It has gone to that directory and start applying all the YAML files that you've seen. Here you see the deployment, the route, the service, and the creation of the namespace. So everything happens automatically. I've just applied that file, and it just updates my cluster. Of course, what's happening if I go there to any of these files, which is this one. We'll see it in a few moments as well, this example here. And I said, oh, wait. In my deployment, I don't want to have one replica. I want to have 2 replicas. I just need to go here, edit that file. And when this, probably I will do it with a pull request. And when the pull request is merged to the main branch, ArgoCD will detect that change and automatically will scale up my instance. So notice that every change happens through YAML files. Let's see if it has been deployed. Yeah, my application is up and running. In fact, I can go here. Here is them. Okay. Notice that the application, as you can see, it's just a simple application within a square of color blue. And the square is blue for the following reason. I'm going here, and you see, there is an environment variable saying that the color is blue. Now, what's happening if I am the administrator of Kubernetes cluster, and I don't want to do anything related to GitOps? Because, you know, I've been doing kubectl all my life, so nobody is going to tell me that I need to use GitOps. That's fine. So I'm going here, and I do kubectl patch, kubectl patch. No worries. I've got them. It should be somewhere over here. Maybe it's here. Got a patch. I'm trying to figure out, because it's a long, okay, no worries. It's a long command, and I copied somewhere. But you will have all these examples. I will share with you the links, so you're able also to reproduce at home. Going here, okay, and the command is here. Where is patch? Here. Okay, it's this very long command that I will explain to you now. Oh, -n. Okay. Basically, what I'm saying is that I want to change my deployment BGD, and I want to replace the environment variable to value green. So I'm just patching the deployment, saying now the environment variable is not blue, but it's green. So notice that I applied the change and said the deployment has been patched. I can go here and see here that it has been detected something. So it seems that, okay, the service has been patched, but I'm going to, and it's still blue. The reason is that ArgoCD doesn't allow me to change anything of my deployment. I just did a kubectl patch, and ArgoCD said, wait, you're changing something. This something is different from what I've got in the Git repository. Yes, it's different. Then I do not allow you to do that change. See that if you want to see the other way, if I'm going to here, not here. Here, and I do the following. I'm going to change the Selfheal to false. So now I'm putting Selfheal to false. Okay. not, oh, wait. No. Oh. Now I've changed the Selfheal to false. And I'm going to do exactly the same patch. I'm going to change it to green. But remember that now Selfheal is false, so it means that ArgoCD is just going to detect the change, but will do nothing. It will just apply it. See that now I can go here, and it says, I am out of sync. It detected that something has changed between what you've defined in Git and my deployment file, but since Selfheal is false, I just let it happen. And see that now it's green. Now, if you detect this, you still can go this sync button, you push it, you say, yeah, I want to synchronize, and what I want you to see is that it detects exactly that what changed was the deployment. Notice that it's not redeploying the route, not redeploying the service, not the namespace. It just detected the small change that happens in the deployment and redeploy again. So I can go here, and now, okay, wait. Now it's blue again. Now, if you want to see a more complex example, I'm going to show you an example where I'm going to deploy an application with a database, which is a bit more complicated. This example is examples here. Kubectl apply. And this is a to-do application that it happens a lot of things. Like, for example, deploying the application, creating the Kubernetes service, creating the namespace, booting up the database. But notice that first you need to boot up the database and then boot up the service. You cannot boot up first the service and then the database, because then you might get some problems. And what I want you to see here is that you can do that in ArgoCD as well. Let me go in the to-do application and see that the resources are happening in order. First of all, it created the namespace, then the PostgreSQL service. Now it's doing, here, it's deploying the PostgreSQL database, but see that the to-do application is still waiting. Then it creates the schema of the database, because when I've got the database up and running, what I want to do is create the schema. In this case, it's creating the to-do table. And see that, meanwhile, all the to-do application is still waiting. So I'm defining an order of how I want to apply all these resources. And step by step, it will deploy all the application. And this is happen. I can show you also the code, because I'm going to apps, to do, Postgre deployment. You see this annotation? I'm just saying sync wave 0. So this is how you set the order in ArgoCD. In this case, I'm saying that this resource should be applied as a 0 file. Then, if you see, for example, the to-do deployment, which is the application itself, it's sync wave number 2. So when ArgoCD tries to deploy all these YAML files, it will order based on sync wave and applying them step by step. You'll see that at the very end, the to-do application is there, is up and running. And, okay, I think that it's a slash to-do.html. And you see here the to-do application up and running. I can do DevOps UK, and it's inserted. Okay, now we still have 6 minutes, and I want to show you a full example of Tecton plus ArgoCD. Okay, prepare your mobile phones, because if you want to play Pac-Man, just try to scan this. I think that it should work. And if not, it's a bit a lie. link, so I will share with you. In theory, if you scan this QR code, you'll get a Pac-Man, and you can play Pac-Man. I don't know if it works or not. If not, this is the URL. Okay. And the Pac-Man is here. And okay, so this is me playing. I'm not so good on that, but okay. Now I've got the Pac-Man. It's the Pac-Man game. You can play it. I can even eat some of them. Okay, now I want to update my application, and I want that the background, instead of being black, I want to be green, for example. Now, I've got here the application. Okay, let me open the code. I'm a developer. They asked me to change this from black to green. I think that it's over here, CSS, Pac-Man CSS. Notice that here it's black. Let's change to green. Green. Or green-yellow, which is even... Now, I need to git add dot, git commit. Okay, I'm the developer. New background color. I'm going to do a push. Now okay. Now I've just pushed my code. Now I want to start a pipeline. See that my application, you can see it here as well, it's an ArgoCD application. Here is this Pac-Man app. I need to go to source main Tecton, Kubernetes Pac-Man build. This is where do that. Well, I have all the tasks. You see that I've got one task. And I'm going to do a kubectl apply -f of the file. Here. So I'm just going to run this task. This task, you'll see that it's fairly more complicated because it's just creating the application, creating a container, pushing the container to my registry, and sending a pull request to the Git repository with the new version. You see that it takes a bit of time, and then I'll show you them. Come on. The repo is, okay, it works or not? Okay, no. Tcn tier list. Tcn for now. Well, I can show you them first. Build app task. You see that it's a bit bigger. I'm just creating a task that it receives some input parameters, like, for example, the container image that I want to use and the credentials. Because if I need to push content to GitHub repository, I need to set the credentials to push, to have the rights to push that file. So I put it here, the parameter. Then here is the input source again with the Git. This is a Maven project. Here I'm configuring all the parameters to push my image. And finally, here, you see that there is another step that is using customize, that basically it just gets the Git repo, create a new branch, configure Git, set the image to the new image that I've created, so the version 101, and then do a git add, git commit, git push from the branch that I've created to the main branch. Tcn, let's see if how it's going, if it works. Okay, now you see that it says build success, switch to the new branch, new version, updated. to the version 101, and it says, okay, well, all the information of Git. Then, if you go here, you see that ArgoCD automatically detects the change and say, hey, there is a new version. You see here that this new BG is the comment that I've set, and it has deployed the new version. In fact, I can even go here. Oh, wait. Well, this is, you see here, this is what I've changed it. You see the version from 100 to 101. And if I go to, I think it's more, you can, no, more, okay, I don't remember where, but you can see, both of the change. And okay, it's up, but I want to show you that. Now it's green. Okay, so that's all. As I said, there is all the resources are there. I've pushed it in the slides. I will share the slides in my Twitter. And dn.dev/Tecton tutorial, if you want to learn more about Tecton. dn.dev/ArgoCD tutorial, to learn more about ArgoCD. And yeah, here is the repo of the Pacman example. So that's all. Thank you very much, and enjoy the conference.